So you try and work on improving mathematics in school. Why is that?
So we've been building computation systems and software for years. And we've watched in the outside world, outside education, how this has really been used to move, everything forward. That's partly why we're in such a technological age. Math is more prominent than it ever has been in human history. But yet in schools, this revolution didn't happen yet. We have computers added into the current curriculum, but it didn't completely change like it did in the outside world. So we see people panic because schools are so behind in math around the world, but in fact it's diverging a lot from what happens in the outside world because they're not using computers to do that math.
I remember that I knew kind of the purpose why we did physics and why we did biology and why we did chemistry, but I actually do not know what was the essence of math. What is the essence of math?
Well, I think math is a process, a really powerful process for working things out. Working things out based on a very logical system that's been developed over hundreds, thousands of years. And I suppose I summarize it as a sort of four-stage process. You have to ask the right questions about the problem. You've got to translate them into this great language of math that's so powerful. You've then got to use that, figure out what answer you want to get, and then do this magic step of calculation, step 3 as I call it, and then go back and take the result and turn it back into the real world of what you were trying to figure out to start with and verify it. And, what's really changed in the last decades is that step 3 can now be done fantastically well by a machine. That was the limiting step for hundreds, thousands of years, and now it's not, typically. The limiting step are the other 3, and so those are what we should be really pushing in schools, not teaching everyone by hand how to do step 3. That's no longer the limiting step there and shouldn't be in schools either.
Well, I remember that when we did not have the right process of doing stuff, it was like an error in the end. So that is what you mean, right?
Yeah, I mean, you can just do so much more powerful things. And, instead of solving an equation by hand, that's a very small equation that doesn't really come up in real life, you can solve a really big equation, just like real engineers do. Because the computer's solving it. The difficult thing is, what question do you want to ask? Which equation did you want to set up? What are you going to do with the answer, and do you believe it? Is the answer right? And those are things we're not really teaching much in schools. So I'm actually saying in schools we could go much faster, much further, more conceptual and more practical altogether. So we have a sort of best of all worlds if we do this right. But that's not an approach people have really taken up until now.
What I wonder, we all have to understand algorithms, because what we now perceive as reality is shaped by algorithm. It comes to us and it changes us, and we reflect that back. So is that true? Is it all about algorithms?
Well, I think one important thing in the world is how do you make processes and how do they work? Now, I guess one way it's happened is, one argument for teaching math by hand is it teaches people about processes. You solve an equation in this way and that's a process. I think it's a much more powerful process to teach, which is how you program things, how you make algorithms, as you're saying. Because that's a process people are doing all the time. That's what drives much of, as you say, modern technology in the world. And I think it's really important. People need to learn how processes work, and and programming algorithms are a great way to do that.
And you said something about whether or not a thing is true or not in the end. Can we really, by adjusting algorithms and going further and further, solve huge problems yeah?
You can certainly solve, just numerically. There are many new things that get solved because you couldn't possibly do it by hand. I guess next year's 2012, which is an anniversary of Alan Turing, who built the first computer, arguably, he would have got an awful lot further if he'd had real computing power today, I'm sure. But he started that idea of being able to work on complexity and so forth. So that's you can certainly get much further in many problems. And by doing that, you qualitatively can make a difference. Because in the end, you discover things that you just couldn't discover by hand because you can't see the patterns, you can't generate enough things. So what I say to people is, initially, yes, you can make a sort of quantitative difference, but by doing that enough, you actually end up with a pretty qualitative difference of what you can find out and what you can do.
As the last question, coming to discover, what are the fields that modern mathematics will have to discover within the next 5 year span of time?
Well, let me say something slightly different, which is where it's really applied, and in a sense, literally everywhere. So in a sense, we're a computation company. We're a math company, and a company that does computation. And over the 20 plus years we've existed, it's notable how much more computation there is in the world than there ever has been. 20 years ago, biologists didn't do much math. Now they do. You didn't have search systems and algorithms for figuring out social networking. These are all products of math. And so you've really got to understand math at that sort of conceptual level to be able to do some of the new things we're doing. It's conceptually much harder than it used to be. So I think what we're going to see is more quantitative math in many, many more areas, more complex ways to use that, build algorithms. But the user of that may be more distant from it. There's more automation layers between the computation that's happening, if you see, and the actual end user. And indeed, our Wolfram Alpha knowledge system is an example of that in a sense. It's got several automation layers between the computation it's doing underneath to generate the answer and the question you ask and the answer you get.
Thank you. Cool.
Good. Thanks.